It's a pleasure to be here. My name is Petr Klomfar. I'm R&D engineering manager at Broadcom, and I have been around the application performance tooling for more than a decade now. Today, I'm going to be talking about greater insights into the application performance management. And maybe allow me for a start to have a short, hopefully short, philosophical window. So I think we will all agree that application performance management plays a substantial role these days with any healthy and competitive organization. Why do I say healthy and competitive? Well, think of it from the perspective of the historical IT technology advancement, right? Back in the days where hardware was basically fresh in its nappies and it was still evolving, we had lack of resources, where respectively the resources were precious. You were forced by nature to actually have all your application programs to be optimized down to the level of the instruction level, because there was not instruction to spare. At that time, we did a really good job. But then we hit a milestone where there was a light speed development in the technology, which basically made the computing power available to the masses and much more accessible. At that point, I dare to say that we have let our guard down, because many people have chosen to beat the problems, simply beat the whale with the amount of a cache, and basically more power, more CPU, more memory, you just paid it and everything was okay. It's not too far in a distance past that we have been forced back into the trenches. If you think about it from the perspective of how market has crystallized, how the competition needs to grasp for the market share, it reintroduces the hunger for optimization, and especially if you take a look on a mainframe in regards of, for example, a introduction of tailor-fit pricing. This is where every second and every application that is running makes sense and counts, let's say. So every improvement and every innovation, first we need to ask ourselves the basic premise question, right? We need to set up a baseline and understand the customer pain points and challenges. What we have been hearing from our clients in this regards is that mainframe is a black box when it comes to end-to-end visibility of the applications, mainframe applications, and specifically when you talk about the individual performance data. Mainframe applications can be really high, complex individual pieces of work, and any attempt to modernize usually poses a high risk, and it is typically a slow approach and costly thing to do. Next one I have is the optimization costing the ROI. So it is typically difficult to optimize the performance and resource utilization, especially hard to figure out what is your scope, especially hard to figure out what is your entry point, what are the applications mostly worth to optimize in general. We also are talking here about the return of investment. I'm coming from the optimization space, and typically the return of investment for all the applications that I worked with is pretty fast, but you have to be smart and reasonable with it. So let me have a mini intermezzo here. So no application optimization measurement or optimization in general comes for free. It's always an act of balance. I'm having in my mind always the Pareto rule, the 80-20 division, where you are basically saying that the 20% of your applications are typically responsible for 80% of your performance issues, and 20% of your tuning effort can result in 80% of the performance gains. It's quite important for the later of my presentation as well. When we are talking about the last challenge that we are seeing here, it's the root cause analysis of poorly understood applications can be very difficult, and the subsequent issues are definitely impacting your resiliency and the cost of your operations. Now, how to get out of it? What is the way how to address these challenges? So before I answer the question what to do about it, I think it's worth actually taking a step back and looking at how we do things today. So optimization is a multi-role, multi-skill environment, and where every organization is striving to be excellent in the space, you need to take a step back and look at your tech stack holistically, right? So we typically talk here about the top-down approach. From this perspective, in each of these stages, you have a different roles, disparate responsibilities, different applications. That on its own brings a set of its own challenges. But let's take a look on the stack, right? We're starting at the top from the satellite point of view. So overseeing the machine utilization and capacity constraints is a must place to start, and it's a great way to actually get yourself going, right? But then you are coming to a pilot's view and the control tower. So the pilot's view in its own is from perspective of looking system-wide at your applications, understanding what is running, and the control tower point of view. This is where I see basically a gap, and it allows, it bridges the gap with the overlap in between of the ground level and the in-depth analysis versus the application optimization at scale. And this is actually where the application profiling, and one of the products that I'm going to be talking about shortly, plays a significant role and possesses a unique place on the market. So application profiling and AP4Z application profiler for Z in this instance is a product which is built from ground up to be very lightweight, and it is built up to monitor the application at scale 24/7 continuously, and with very little impact to customers or the user resources. When I say that, the overhead typical of the application profiling in this sense is we deem about less than 1% of the workload as an overhead. But the measurements with the clients actually showed us it's around the ballpark of 0.1%, which is a fantastic result for a product like this that is doing things at scale and generally in the near real time.
So where are those numbers coming from?
We are having reports from our clients in terms of how much MIPS they are using and versus what is being attributed to the AP4Z. And again, we are coming really to 0.1%. Thank you. So I will still stay with the AP4Z for a second. So AP4Z in general address three main use cases, or three key use cases here. They are related to the challenges that I mentioned in the beginning, which is the optimization, troubleshooting, and modernization. So from the optimization perspective, and I remember when we talked about the Pareto rule, it helps you to really identify the scope of your operations, identify which applications are your hotspots, and to which you really extend your strength. It allows you to monitor the before and after optimization behavior of those applications, and it basically provides it in a very easy, understandable way. Now let's say the modernization. One of the challenges with the modernization was the complexity and the risks related to not understanding your application. Again, the information that application profile can provide you is to understand your application more and have a better plan of attack for your modernization effort. Essentially, boosting up the return of investment and lowering the risks. And one last thing that I will mention here is the troubleshooting. So from the troubleshooting perspective, application profiler works at the level of the modules. And it can really assess the CPU usage and other metrics at the module level and across the scale. It can really help you to detect potential security integrity issues or exposures, because it can see unexpected runs or changes in your versions of the products in general. And it also can provide you a good focal point for your application deployment for your QA people who will basically have a chance to see that this portion of the application is really the one that has been touched by the introduced change. I will still mention one thing that I really love about AP4Z, and that's we call it first failure data point capture. And as in contrast to what you have with the taking a dump, for example, when the transaction fails or abandons, AP4Z can actually record what led to that point of view, and it can play it back. So you have a trace from how the application or the transaction was behaving before it failed, which is actually a really good information. Now, coming to the ground level point of view, so from this perspective, this is where the in-depth analysis are really living. They are typically very powerful tools. Here, I'm typically talking about Mainframe Application Tuner. That's the one that my colleagues has mentioned in the previous segments as well. And the Mainframe Application Tuner is a workload analysis tools, which is a low density and it is non-intrusive. It doesn't alter the code in any way. It can monitor pretty much any thinkable workload on a mainframe. So all of the IBM subsystems for GL, Adabas Natural, IDMS, Unix services, distributed portions in terms of the Java applications measurement and so on. And the beauty here is it can analyze the issues up to the statement level of the code. So it can really attribute the delays, activities, loopholes, bottlenecks, inefficiencies, hotspots, up to the statement individual instructions. So where is it? Yeah, this is where the synergy of these products is really coming forth, because where AP4Z as an application profile can be a very proactive solution, the math is like more reactive and ad hoc, dispatch me here and give me the information. And I'm slowly but surely leading what does it mean with the observability platform. So still bear with me. So you say, okay, that's great, Peter, because you have lots of data that are otherwise hard to get from different sources, and it is, somehow connected together. But is this really the way that is basically being the wow factor? This is where WatchTower, the incremental observability from Broadcom, the WatchTower platform bears its fruits, because it is a fantastic platform for optimization products like these to integrate with, and finding the silver lining of the contextual information in comparison with also other WatchTower players. My colleagues has been representing different products here. So talking about SysView or Ops MVS, all of those products within the WatchTower can actually utilize these solutions and say, hey, I have a dynamic threshold broken down or just breached. And it will say, dispatch me the Mainframe Application Tuner to get me the granular level of details. And one step back that I will say, with AP4Z, I have said that the overhead for the at-scale monitoring is less than 1%, more like 0.1%. With the granularity of information for the in-depth analysis, you would naturally expect that this is higher, right? So Mainframe Application Tuner overhead while monitoring any of those workloads is typically somewhere close around 3, maybe 4% of the application run. And this is why you need to have it focused, and this is why the integrations of these products is really much helping the case. So now coming to the big wow, right? So again, just to reiterate, typically, the mainframe teams are often lacking the expertise and time to optimize and modernize their applications. They don't necessarily have the link and idea where to start, and most of their code is older than a decade, and I'm being conservative here, right? So again, WatchTower, in this sense, the products integrating with it are allowing more closer collaboration in between of the products, cutting down the MTTR with any potential issues and resolving the critical problems, streamlining the processes, that's the big thing as well, and allowing the individual players within the observability to communicate better. Simply, when you are passing the information from stage to stage, from operator to subject matter expert, optimization expert, performance engineer, and so on, you allow the next person to hit the ground running rather than starting from a scratch. This is, in my way, at least, the multiplayer that has been mentioned in the previous segments here as well. So how these products like AP4Z and MET integrate with the WatchTower, at least these days? So it's a continuous process. But with AP4Z, we can really call out a call graph or call tree of the individual module interrelations. And this is similar to what the user has been experiencing, for example, with Topology, another player from the WatchTower platform. It can visualize the trends in the CPU usage and elapsed times, as well as it has a very nice distinction of which languages your operation at scale is using on the mainframe, and you can very much drill down even for a COBOL in this sense and see which of your COBOL applications are compiled with version of a COBOL. And Derek, you can hold me here accountable, because if I refer to the data from IBM and referring back to the baseline, simple recompilation of COBOL application within your version bears a benefit in a performance tuning. If we correlate it back to, I don't know, 4.5, 10 to 20% CPU reduction usage on just recompilation. But I'm leaving out the thing that you can utilize the arch parameters and optimization parameters, and then in that case can even take you to the 75% savings on the COBOL usage. So again, a lot of those informations you can have in a modern way, easy way to consume, where typically the in-depth analysis from the user perspective requires a seasoned SME to actually digest them because of the complexity. The AP4Z, in a sense, is giving you the way in the relatively easy way, which enables not only the seasoned SMEs, but also architects, developers, and even new hires in the company to digest through the information. So I'm loving it, and I will take one more step to Matt before I just wrap up from my at least perspective. So Matt integrates with WatchTower in a sense, specifically through the alert insights, right? So Matt can also, not only the other players within the portfolio, which can invoke Matt and say, hey, this is something is burning and dispatch me the application performance in-depth analysis. But Matt can also watch for the CPU time, elapsed time, XCCP or IO operations or service units. And based on these thresholds, which are dynamically refreshed and learned from the SMF records, it can issue an alert and provide a summary of that immediate measurement through the alert. So the silver lining is still being cascaded and passed from role to role, and it's beautiful. And I really like how these products are actually mutually benefiting from being part of the WatchTower ecosystem, because thinking of it, WatchTower also allow us to do more on-point and faster development of our applications, because it allows us to collect more valid and quick feedback and validation with the client portfolio at the end. So I'm personally looking forward what the optimization products can do and how great insights they can provide within the WatchTower platform going forth.
Well, just a quick statement, Peter. You're absolutely right about the COBOL side. I think Tom Ross is here this week and he's talking about exactly that, what version you should be using to compile and what performance metrics you expect to see. So
yeah, there are shows which have only and only COBOL, right?
Yeah, but the OS vs COBOL, still a lot of it about. So, it's an important point.
Absolutely.
Is reliability a big? What's the performance from your perspective? Performance can mean a lot of things, a whole ton of things. You're talking a lot of resource utilization that leads to a typical meaning of performance just around roughly say speeds and feeds. But there's really a lot more to it, I think, especially with mission critical applications. So are there particular things that you would call out? I always associate reliability with these types of applications: reliability, availability, uptime, failovers, that sort of thing. But I can't tell if that's what you're talking about here as the pain point that leads people to say, hey, we probably do need to modernize. What would you say they are?
My point of view on this one, that these tools are very much suitable. The quickest return of investment on these tools is typically in production, right? But they can very much live in the test dev containers as well. So it depends whether you are approaching it from the AI ops perspective or operations, or whether you are living in a DevOps space. And I always, in my mind, slip back to one of our VPs who had an article about the value of a second. So respectively, let me step back. The performance in my case is typically boiling down to, meeting the SLAs and getting the biggest bang for your bucks, because again, the competition out there is ferocious and you really need to stay on top if you want to win in the market and have the client user bases you need. And one of our VPs actually was saying about the value of the seconds. And I will try to be quick here, right? So the whole article was about, take a value of a second, for example, in sports. When you have a F1 car racing or someone competing for a gold medal, even, a split of a second difference, tenth of a second can mean that you are not on the podium and And it's a bad thing for you because you were training for it and everything like that. But when you take it from the perspective of the sports, you typically have another season, another event to grasp for the victory. When it comes to business, it's much more worse because if you, for example, take one of the big credit card companies, which is having a 10 trillion volume of going annually, for them, if you just do the math, it's like $300,000 per second for any of the severity one reaction time before the people will cascade the information and react. So the MTTR is really critical here. And there are much more other things related to that. It's a monetary impact. Obviously, millions of dollars are going out of the door if you are not addressing your issues quickly. And that's where WatchTower as observability being proactive can help rather than reactive. And also you have a reputation hit and loss of a trust and so on and so on. So this is really what performance boils down, at least for me internally.
Performance is performance. Performance is it's clearly Broadcom having customers come to them and say, we did the math and you know we're losing an average of $1 million an hour or whatever it is because of this particular application that we are in production. We're concerned about updating and upgrading. Come help us. And the terms of that have to do with, you said MTTR, have to do with speed, which is the typical baseline meaning of the word performance. Mm-hmm. Really speed more than any other elements of it.
The thing is, in a mainframe context, when we talk about performance, we also talk about efficiency, because if we are inefficient with the code by like using an old compiler, that drives CPU usage, which drives software cost license. Yeah. So when we talk about performance, we're talking about the end user's experience, but also how efficiently we're using the resources, and that all comes under that umbrella of performance. And that's where it can get a little blurred at times, because if I'm the systems programmer, I want to make sure I'm keeping to whether I've got tailor fit pricing or rolling 4-hour average. I want to keep the utilization of the machine down at a level that meets my budget aspirations, where the end user, the business, wants sub-second response time. And sometimes you can't have both.
So SLAs, delaying costly hardware upgrades, those are definitely things. And one, you are reactive to a problem. One, you are preempting the problem. And the third time, you are trying to utilize your box to its maximum potential. That's what optimization is, and it's a complex subject, I know.